All right, everyone. Well, I hope that you're doing well. Hope you're having a nice weekend, and that again you're into the swing of things here, and being able to work toward the end of the semester with your classes here. So I didn't find, couldn't think of a really good way to connect fish to this particular lecture, but knowing me, I decided to connect fish anyway. Have some fish in here anyway. So this is a picture of one of my favorite fish. It's a fish called the snow trout. It's actually a minnow officially, but its common name is a snow trout. You can see it kind of has that pink band on it, almost like a rainbow trout. If any of y'all like to go fishing in the spring, another activity which is not happening now that normally would be, right? We'd be out. This would be the season to go out fishing. This is the river that we caught this particular fish from. It's the Kali Gandaki River. It's not far from the Tibetan Plateau here. It's flowing downstream. And so we're up about 3,000 meters in elevation, so up over 10,000 feet at least. And this is our team. So again, this is when I was in Nepal doing research, and this is a picture of our team. The two people on the right there are actually students at Kathmandu University that were coming out collecting data with us and conducting research. The guy in the middle there is he served as our driver and also helped in the field, and he was from the plains of India down south. And then Amr, just to my left in that particular picture, he helped us out in the field with all of our research. And we had a pair of waders for him, but he actually didn't want to wear them. He didn't think it was that cold, so he actually wore shorts on this particular day. He was a tough guy. All right. So just a reminder, do keep on top of our two articles that I'd like you to read and do an annotation for. I hope you figured out how to do that from our first article. So two more, the next of which is actually due on Monday, and then the final one is due on the 23rd, the next Wednesday. So hope you're able to stay on top of those. Again, this is a screenshot of our Moodle page, so you can go on there and check those out. All right, so our topic for today is air pollution, and this is some data from a 2018 study. Just showing some of the health impacts that air pollution still has in the U.S. I think we often like to think of air pollution as a problem that's restricted to countries far from us, or the global south, or what we sometimes refer as underdeveloped countries. But in fact, air pollution affects health of folks in the U.S. As well. This study showed that children living in New York City neighborhoods where asthma was more common, they needed more emergency care, suffered more from exercise-induced wheezing, and that in these particular areas, concentrations of air pollutants were higher. So things like nitrogen oxide, small airborne particles, things like carbon, so smoke and things like that, were a lot higher in these areas than in places that didn't have cases of asthma. And this study looking at these needs of emergency care and these exercise-induced wheezing, these studies controlled for household income and healthcare access. So it looks like air quality is really what was influencing these health outcomes in these New York City neighborhoods. All right, give you some data on air pollution in the U.S. This is about 500,000 people in the U.S. that die each year due to cardiopulmonary disease, right? Disease of the heart and lungs linked to inhalation of fine particle air pollution. So this is most typically smoke, and is very, very dangerous because it's so small it can get into our bloodstream very easily from our lungs. Coal-fired power plants, the largest contributors to air pollution. So again, we'll talk about renewable energy here in a couple more classes, but this is one more reason that we need to switch toward renewable energy, is to make our air cleaner and reduce the health impacts of air pollution. Some of the chemicals that were responsible for that are soot, sulfur oxides, nitrogen oxides, mercury, and CO2. Southern California is really the place that's been hardest hit with air pollution because um, of the air circulation pattern. Something that can also affect us here in Asheville, being in a valley, but Southern California definitely hit quite hard. Okay, so let's define a couple of terms here. So when we're talking about pollution, one thing we want to define first of all is where it's coming from, and so we can talk about point sources and non-point sources of pollution. And so point sources are specific spots that discharge large amounts of pollutants. So for air pollution, the clearest example would be a smokestack, but there could be others. You know, a lot of these are going to be you know, waste disposal mechanisms, but you know, again, smokestacks are the most the clearest example to think of. So contrast non-point sources, and non-point sources are interesting because really they're defined as being comprised of lots of small sources. So it's more diffuse. So really, so a point source, remember, is a location where a large amount of pollution is emitted. Non-point sources, a large collection of lots of small sources. So if you can think of any examples of these, I know one that comes to mind, probably for you as well, are vehicles, right? Inside every one of those cars, there's a combustion engine that is burning fossil fuels, right? And so it's emitting CO2, carbon monoxide, all those kinds of things. So our highways, our road systems are good examples of non-point air pollution sources. All right, and so we can break down the types of pollutants that we're dealing with. So we can talk about primary versus secondary pollutants. So primary air pollutants are chemicals that are are emitted directly into the atmosphere, and they're dangerous in that particular form. Right? We have other pollutants in the air that are the products of various reactions, but primary pollutants emitted directly into the atmosphere. Things like carbon dioxide, right? So if we're burning coal, it's going to go on up into the atmosphere. Same thing with any kind of fossil fuel. Also, again, the very fine particulate matter, the byproducts of combustion, combusting solids. So very fine particulate matter, you can see is on the order of 10 microns or 2.5 microns. To give an example of how small these particles are, that black circle there is giving you the diameter of a human hair. So these particles are tiny, and the problem with them when they're that small is that when you breathe them in, they can pass directly across the lining of your lungs into the bloodstream, and so they're very dangerous. So all these are pollutants that are put directly in the atmosphere. These are examples of primary pollutants. So secondary pollutants are a little bit different. They're pollutants that are in the atmosphere that are the product of chemical reactions in the atmosphere. So you know, these are pollutants that we have to deal with that we didn't put directly into the air, but they've reacted. They're the product of reactions. And so I don't know if you can think of any examples of these. There's a couple well-known ones. You might not know that they're secondary pollutants. So ozone. Ozone is this sort of mixture of organic compounds that react with the light of the sun. So ozone is triple O. It's 3 oxygen molecules bonded together, and when it's up in the stratosphere, the ozone layer is very good because it shields our skin from ultraviolet radiation. That's kind of our UV radiation shield. But when it's down in the troposphere near the ground level, it's a respiratory irritant. It's harmful to plants, and it's a problem. So ozone, it's a product of the reaction of different what we call hydrocarbon molecules and others in the presence of sunlight. The other is nitric or sulfuric acid, and so sulfuric acid, nitric acid is the product of reaction between nitric and sulfuric oxides and water. And so those nitric and sulfuric oxides go into the atmosphere most generally by burning of coal, and they react with water to form acid. And then, of course, that acid can come back to the ground as acid rain. So what are the primary air pollutants that we're dealing with in the United States? So carbon monoxide is the biggest one. Again, it's a byproduct of burning fossil fuels. Second biggest is nitrogen oxides, and then particulates. Particulates, again, are any kind of, essentially any tiny particles in the air. So volatile organics, those are a whole variety of chemicals that can get up into the air from all sorts of sources. Some of them natural, interestingly enough, but also from a lot of different pollutant sources as well. So we think of sources of outdoor air pollution. You saw that carbon monoxide was the biggest pollutant, and so if you know something about what produces carbon monoxide, you might have an idea of the sources. And so really the transportation industry is our biggest polluter, right? It's all those cars driving around, it's the airplanes that are driving around, flying around, although not so much now. And so it's just another reason to try and carpool, to try and bike instead of driving. It's really our largest polluter in the United States. So why is this a problem? What is it that air pollution does that's bad for us? Well, here's a table looking at a couple pollutants on the left, the source that they come from in the middle, and then their effects on the right. So we've got particulate matter, nitrogen oxides, sulfur oxides, carbon monoxide, and ozone. And if we just look at the effects over there in the right column, you can see all these things aggravate respiratory illness or irritate the respiratory tract. Carbon monoxide is especially bad because it has a higher affinity for hemoglobin in our blood than oxygen does, and so carbon monoxide actually kicks oxygen molecules off of our red blood cells and replaces them with carbon monoxide. So it's very, very dangerous. But so a lot of these are pollutants that are going to have strong impacts over time. It's going to be more chronic exposure that we're going to see rather than acute exposure. So this air pollution is kind of a chronic cumulative effect on our bodies. Okay, so there are certain classes of air pollutants that the Environmental Protection Agency keeps an eye on. So particulate matter, as we've talked about, or at least mentioned briefly, nitrogen oxides, sulfur oxides, carbon oxides, hydrocarbons, and then ozone. And so I made some of these green. I wonder why you might think that I made these green. And that's because they're greenhouse gases. So these nitrogen oxides, carbon oxides, hydrocarbons, and ozone are greenhouse gases, which are contributing to global warming, as we'll talk about later on in a couple of days. And again, these nitrogen oxides and sulfur oxides we're concerned about primarily because they can react with water in the atmosphere to create acid rain. And if we look at precipitation of rain across the United States, you can see the darkest green color is pH above 5.3. The warmest red color is pH below 4.3. And of course, the pH of 7 is neutral. So it's interesting that even the most basic rain, the rain with the highest pH, is actually slightly acidic. And the reason for that is because the naturally occurring carbon dioxide in the atmosphere reacts with water in the atmosphere to form a weak carbonic acid. So because of the CO2 in the atmosphere, rain is naturally slightly acidic. But you can see if we're in areas downwind of coal-fired power plants especially, there's some spots where the pH can get much lower, 4.5. And it's worth noting that the pH scale is a logarithmic scale, right? So a pH of 5 is 10 times as acidic as a pH of 6. So, a difference in one pH unit is a difference of 10 times the amount of acidity. So I don't know if anybody has been to Mount Mitchell. If you haven't had a chance yet, you should go. It's beautiful up in the Black Mountains. It's the highest point east of the Rockies, highest elevation point east of the Rockies. But interestingly enough, Mount Mitchell, if you look in a lot of environmental science textbooks, it will talk about Mount Mitchell as sort of the case study for acid precipitation. And in fact, in the mists at Mount Mitchell, pH has been recorded as low as 2.1. Now that's about the acidity of grapefruit juice, right? So I don't know if you've ever squirted yourself in the eye with grapefruit juice when you're eating it in the morning or something. It really burns, and so you can imagine having mist with that kind of pH, what it would do to the forests. And so this has really done a number on the evergreen forest at Mount Mitchell, and so it's unfortunate that that's happened. But one thing I would say is that the acid rain is actually a lot better than it used to be. The state of North Carolina actually sued the state of Tennessee because coal-burning power plants in Tennessee were polluting the air, and that pollution was then blowing over into North Carolina, and that was leading to the acid rain. And so this lawsuit actually caused the state of Tennessee to reduce the pollution of those power plants. And so the precipitation around Mount Mitchell is a lot better than it used to be. Okay, and then another secondary pollutant is ozone. So as I mentioned, ozone is O3. It has kind of a triangular configuration with those 3 oxygen molecules bound together. So ozone is kind of like the Dr. Jekyll and Mr. Hyde of the atmospheric chemicals. When we have ozone in the stratosphere, in the highest layer of our atmosphere, it's a very good thing. That's the ozone layer. That is what prevents ultraviolet radiation from getting to the surface of the Earth. And so we would be at much higher risk for skin cancer and sunburns if the ozone layer was not what it is. Now, I've already mentioned how ozone, when it's down in the troposphere along the surface of the planet, is a respiratory irritant and not good for plants and things like that. But when it's in the stratosphere, it shields us from UV rays. Now, one of the things scientists noticed in the 70s was that the amount of ozone in the stratosphere was declining. So you might have heard of the ozone hole, the hole in the ozone layer. It was concentrated over Antarctica, actually. And what was happening was that certain chemicals, which were created by humans, used by humans, react with ozone and break it down into O2. And so CFCs, or chlorofluorocarbons, are the best known example of this. Chlorofluorocarbons, CFCs, for a long time were used as propellants in hairspray. They were used as refrigerants in air conditioning units and things. If you look back in the 1980s at all the hairspray that people were using, go check out the movie Dirty Dancing. You'll know what I mean. I'm sure that contributed to the breakdown of the ozone layer. But regardless, scientists were able to figure out that these CFCs were leading to depletion of the ozone layer. So this is, I try to share good news with y'all as much as I can. So this is a piece of good news. So once scientists realized that this ozone layer is what's protecting us from UV rays, and that these CFCs are breaking that down, they signed a treaty to stop making CFCs. It's called the Montreal Protocol. It was signed in 1987, and it's considered, as it says right there, one of the biggest environmental success stories. You know, we hear so much nowadays about the Paris Agreement, or the inability of countries to work together to sign these international treaties. But the Montreal Protocol was a great example of countries coming together to do this successfully. And so, looking at the amount of CFCs produced, you can see after 1987, in just about 5 years, we'd cut the amount of CFCs produced in half. We decreased it by more than half. And atmospheric levels dropped as well. So again, these are data up through just about 2020. And then there's estimates. You can see these lines continuing further down as far as how low these numbers are expected to get. So you saw this pretty massive increase in CFCs and some of these other compounds as well. Pretty massive increase on into the 80s, and you can see even though we reduced our production, the amount of CFCs in the atmosphere kept increasing until about the year 2000, but now they're dropping, and we hope that they'll continue to drop. All right, so we've had some pieces of legislation with the aim of addressing air pollution, and really the first piece of legislation that came down the pipe, that environmental legislation in the 70s, was directed at protecting our air. So the Clean Air Act of 1970 set standards for air quality and set limits on how much pollution could occur. It set aside funds for pollution control research. And it's like a lot of pieces of environmental legislation. It's called litigation driven. So if I feel that the air is polluted in my town, I can actually sue the state for violating the Clean Air Act, and then that requires the state to come and check it out and make sure that the air, in fact, is meeting the standards that they need to be. Then in 1990, there was a renewed focus. So basically in 1970, we got really good at reducing point source pollution. Point source pollution. And there was a great amount of improvement in air quality. But there were still a couple special cases that needed addressing in the 1990s. And so the non-point pollution issue really became a biggie. And so the Clean Air Act of 1990 strengthened standards for auto emissions to try and reduce the amount of pollution coming from automobiles. Those standards, unfortunately, have been weakened under the current administration. And it also took on acid deposition, so this idea of acid rain it addressed. And it looked specifically again at stratospheric ozone depletion to try and continue the momentum we had from the Montreal Protocol at improving the ozone layer. It introduced the idea of emissions trading. Again, this cap and trade system where companies, we talked about that way back in the beginning of class, if you remember, where companies, it creates a market in pollution essentially, and then companies can trade or sell those permits. So the EPA has 6 pollutants that it keeps a close eye on, 6 what we call criteria pollutants in the U.S. So here they are: carbon monoxide, sulfur dioxide, nitrogen dioxide, tropospheric ozone, again that's the ozone in the troposphere near the Earth's surface, particulate matter, and lead. And so these are all pollutants that the EPA is legally required to manage. So how are we doing across the U.S. at meeting the standards that the EPA has set for us? So this is a map that's a couple years old, actually about 4 years old now, but it just looks at the number of pollutants that counties didn't attain. In other words, the number of pollutants for which that county did not meet the standards. And so green means there was 1 pollutant that they didn't make it for, blue is 2, yellow is 3, and so on up into that red. And again, just looking at this map, You can see Southern California, Central Arizona, right? These are areas that have really struggled with air quality. North Carolina, at least in 2016, was doing quite well. It didn't have any counties that were at non-attainment. Now, there's actually one pollutant that every now and then exceeds the recommended levels here in Buncombe County. I don't know if you may have heard of this, but it turns out that tropospheric ozone at times can build up to pretty high concentrations in Buncombe County. And this is when there's hot days, lots of sunlight, because sunlight is what converts those organic molecules to ozone. And it's because Asheville sits in a valley, and so when that pollution starts to accumulate in the valley, it can just stay there and not get cleared out. And so that's why we can have some issues with that. But you can see, again, in the western U.S. particularly, a lot of struggles with this. Just to give you one more success story, when I was a kid and we would drive around in the car, you pull into a gas station, and two things would happen that don't happen anymore. One was that somebody would come out of the gas station and offer to pump your gas, which they don't do anymore. The other thing that would happen is that they would ask you if you wanted leaded or unleaded gasoline. Because lead in automobile fuel was phased out through the 70s and 80s. Lead had, been present in gasoline from the early days until scientists started to realize that it had some bad health effects, particularly on the development of the brain. And so eventually cars were made that were made exclusively that required unleaded fuel. So because of that, the amount of lead consumed in gasoline usage in the middle there, the amount out in the environment on the far left, and importantly, the average amount in blood as well, declined a great deal over the late 70s into the early 80s. Now, there's still lots of lead out in the environment. If you've ever seen the show Cosmos, there's a really cool episode about lead and showing that lead is everywhere on Earth. It's even in the Antarctic and polar ice, just because we burned so much of it in our fuel for so long. So it's still out there, but it's definitely a lot less than it used to be, and it's another good example of us being able to eliminate our reliance on a dangerous chemical. So I think I mentioned as well back in the beginning of class, that the average American spends about 90% of their time indoors. So we need to be thinking about indoor air quality as well as outdoor quality. So in almost all cases, indoor air contains higher concentrations of pollutants than outdoor air. We've kind of seen that with COVID-19, right? Where it's safer to be outside, where the air is circulating and it's not concentrated so much. So what are the most dangerous indoor air pollutants in the developed world? Let you think about that for a moment. You're exactly right. Exactly right. Tobacco smoke. That's not nearly as much now as it used to be. Radon, which is a radioactive gas that can develop in the foundation of buildings built on bedrock that contains small amounts of uranium, which we actually have here in the mountains. So I'm sitting here in my basement actually making this video, and right next to me is our radon remediation system, which just pumps air out of the basement. A lot of houses here have it to keep levels below a safe threshold. And then the third one behind tobacco smoke and radon are volatile organic compounds. You know that new car smell that people talk about? Yeah, those are volatile organic compounds, or VOCs. Organic compounds not very good for you. If you've ever been in a building that's just had a new rug put in, my gosh, that smell as well, those are VOCs. In our offices, we had new rugs. They essentially put in the offices, I guess 7 years ago. And for that first year, when you got in there in the morning, it just smelled so bad from the chemicals coming out of these the carpets and stuff. So So those smells, you want to try to air it out when you smell those, because those are these volatile organic compounds, and they're not good for our bodies. So you can actually get it's so bad that you can get what's called sick building syndrome. So this is what happens when buildings don't have sufficient circulation. And this is a picture of some black mold in a home, which is in pretty bad shape. Um, but essentially, when you have poor air circulation, it gives chemicals the chance to accumulate indoors. And it's interesting. In the 1970s, we had the oil embargo. The Middle East, reduced the amount of oil that they were producing, and so that made it much more expensive to heat buildings, because a lot of them were used heating oil and that kind of thing. And so building standards actually were changed so that there was less air moved through the buildings. So it would be cheaper to heat them, if that makes sense. But the problem was that created more indoor air pollution problems. But so now, the amount of air circulation required in public buildings is a lot higher than it used to be, and will hopefully help with these kinds of issues. So, with that in mind, I hope y'all have a chance to get out and get some breaths of fresh air. Go out, get your socially distanced exercise done, however you do it. Go for a jog, go for a hike. Whatever you do to get exercise, go out and enjoy some of that fresh air in the Appalachian Mountains. We're fortunate to be in a really nice part of the country here, or wherever you are. Go out and get some fresh air. It's good for you. So that's all I have for you with this video, and look forward to seeing you at the next video. Again, you can stop by our Google Hangouts or let me know if you have any questions. And be sure to check out Moodle for our articles for you to annotate and put comments on. Hope you all are doing well. Take care of yourselves. Be patient. Do your best. And we'll all be out of this situation pretty soon. You can do it. Bye.